Hello everyone. My name is Marko Hotti and I'm Senior Technical Product Manager for Microsoft SQL Server. Today you have been watching a lot of videos about new features and capabilities of SQL Server 2016. And in the end of the day, it's all about data. And today in this video, I'm going to talk to you about the full life cycle of data that you can handle and manage with SQL Server 2016. So what do I mean with the life cycle of data? First of all, in transactional systems, when we have ERP system or CRM system or any kind of transactional system, the data is hot. So what we want to do and what we want to achieve in the transactions is really to store the transaction and the data as quickly as possible, and maybe also analyze the data right away so that we can actually see what's happening in our operational systems. And for that, in SQL Server 2016, we have great enhancements in in-memory OLTP, which basically means that the transactional tables are totally in the server memory, and we can do the transactions totally in memory. And with operational analytics, you can analyze the data right away so that you can see how the data has changed. And also the latest transactions are always available for the queries. With warm data, we mean data that is still changing a little bit, and we analyze that for different purposes. For example, you want to see what happened during the past hour or yesterday, last week, last month. And this data might change a little bit. So that's typically the kind of data that we put in the data warehouse for reporting purposes. Then there is cold data, which is typically something that we put in the data warehouse for a longer period of time. We need to have that data online for analysis, but it doesn't change anymore. And typically, this type of data is consuming a lot of storage space. And typically, this kind of storage space is very costly. So you often want to take that offline so that it's not consuming your premium storage. So that's kind of a challenge for historical data and data warehouses in general. Obviously, in many scenarios, data can be really sensitive. So it's often so-called PII data or personally identifiable data, payment card data, social security numbers, health records are great examples of sensitive data that you just want to store securely. In SQL Server, we have had great features for protecting data, starting from transparent database encryption, auditing, column encryption, and so on. And in SQL 2016, we now have great enhancements in that area as well. Then there is data that is generated from existing data. That's a very important topic, especially for data science and for predictions. And in that scenario, we are talking about new data that is generating with the methods of advanced analytics. And typically these days, we use data scientists who write R code to analyze this data and do different kind of things like predictions or classification or scoring of the data based on what we have seen. And there are also other elements to data. Data changes over the time, so there is temporal data. You want to sometimes see what happened to my data, customer data, for example, in the past, and see how the data has changed. And then there is also spatial data, meaning that the data actually has a location. And SQL Server 2016 handles that type of data very well as well. Today, I'm going to show you a demo, which is actually based on a real customer scenario where one of our customers who is doing financial services is using SQL Server 2016 for managing the whole life cycle of financial data. They are offering an execution platform for financial services. And basically what they do is they handle the payment card transactions and also do different kind of predictions and analysis based on that data. They analyze and do reporting, credit scoring, and so on. And since this is a payment card transaction type of execution platform, it basically means that all the transactions need to be handled really fast. So they are using in-memory OLTP for doing that. They also want to analyze the data right away to detect different kind of anomalies and different kind of scenarios. They actually want to see what's going on right now in the execution platform. So they are using real-time operational analytics for this. They also have lots of data scientists who are using R. And traditionally, their data scientists have been using their desktop tools for analyzing the data that has been handed over by IT. So it's a subset of all the available data that they have been using. And the challenge here is that it has been almost impossible to operationalize the advanced analytics. But now with SQL Server 2016, they are able to do that with R services, and they can run their trained R models close to the database. Other challenges, obviously, is that the data is very sensitive. So they have been using security technologies like transparent database encryption and auditing for storing that data and seeing who is using the data. But they also wanted to make their applications trusted so that only the trusted application can access the sensitive data that's stored in the database. And for that, they are using the new always encrypted technology. They also wanted to improve the online consumer experience by offering a longer period of historical data for the transactions for their online services. Previously, that was not possible because the amount of transactions was so huge that it was very expensive for this customer to keep all that data online. So they only could keep the data online for the past 2 or 3 years, and that's all. And now with the stretch database in SQL 2016, they are able to stretch the historical transactions onto Microsoft Azure and just query that data like any other data in the database, only the historical data is now residing in Azure. So let's take a look at the actual demo. So right now I'm a persona called Terry Adams, who is the analyst on this financial services company. And what I'm looking at is a customer engagement map where I see the active payment card transactions that the execution platform for financial services is currently handling. So what happens behind the scene is that they are running SQL Server 2016 always on availability groups to make sure that the payment card transaction system is highly available, and then there is also a disaster recovery available for different kind of problems. They are also using in-memory OLTP technology to make sure that all the payment card transactions are handled in the server memory super fast. Let's take a closer look at what's happening in the system. So what we see here is a real-time dashboard which is generated by operational analytics in SQL Server 2016. We are doing constant queries against the transactions that has been handled by the in-memory OLTP transactions in SQL 2016. And we see, for instance, how many transactions in the last 24 hours we have been handling, what is the average processing time per payment, and how many reward points the end customers have been claiming over the time in different regions. So how do they do that? Traditionally, you wouldn't want to query the transactional tables because they are optimized for fast transactions. And typically you would have some sort of ETL process to actually load the data from the transactional tables and then run the queries from a reporting data warehouse. And then you wouldn't see actually any kind of real-time information there on the dashboard. But in this case, customer is using operational analytics to do real-time queries against the transactions. And I show you just quickly how they look like. So what you see here is SQL Server Management Studio and a T-SQL script that is querying the transactional table. The transactional table is in-memory table, and we have added a in-memory clustered column store index on top of that, so that each time we do a query against this transaction table, we are touching the clustered column store instead of the row store. And I show you just quickly how it looks like from the execution plan point of view. So I run this query, and as you can see, the query executes very quickly. And if I take a look at the execution plan here, we can see that the execution plan is touching the column store index instead of the main table. And so this is the way we do operational analytics in SQL 2016. Now that I have shown you how operational analytics in SQL Server 2016 works, let's take a closer look at this real-time dashboard. As you can see, there is something unusual going on in Europe right now, because it seems like many of the cardholders are claiming lots of reward points. So let's take a closer look at what's happening in Europe. In this dashboard, you can see that the average base rewards amount is around 400,000 points. But in October 2015, there is some unusual activity going on, and we see that end users, cardholders, they are collecting an unusual amount of reward points. And so this might be some sort of early sign that there is something wrong going on. So how does SQL Server 2016 help you find these kind of anomalies? Well, that's the R integration that we have in SQL Server. And let's take a look at how it looks like. Now we are back in SQL Server Management Studio, and as you can see, some T-SQL code and some embedded R code that has been provided for the DBA by the data scientists who have been training and testing the data based on different scenarios, which basically try to detect different kind of anomalies in the payment transactions. And so now that I run this query, we will see that in October we have the most amount of anomalies in payment card transactions. And this is what we are showcasing also in the dashboard. Let's go back to the dashboard and see what's happening in October 2015. Here we can see that there are quite a lot of customers who have been collecting reward points. And what I want to do is actually find who has been collecting the most of the reward points in October. So I sort this based on reward points, and I see that Sally here has been collecting an unusual amount of reward points in October. And this is something that we need to look at. We also see quite a lot of sensitive information here. This is all fake information, but we have credit card numbers and we have national identifiers or social security numbers in this dashboard. And this is something that you don't really want to share for other people. Only trusted people and only trusted applications should have access to this kind of information. So what this customer has been doing is they have implemented always encrypted to first of all encrypt the sensitive columns in the tables, like customer tables, and then provisioning the column master key to trusted applications who only have access to the column encryption key that then encrypts and decrypts the sensitive data. So let's take a look at how always encrypted actually works. So here is my customer table, and as you can see right now, all the sensitive information such as customer ID number and credit card number are in plain text in these columns. And I want to implement always encrypted. So I will show you how that is done. I go to the customer table, right-click and select Encrypt Columns. And this will start a so-called always encrypted wizard, which helps me to protect the sensitive information. So let's see how we do that. I want to first select the columns that I want to encrypt. So I pick the customer ID number and credit card number, and then I choose the encryption type. And in this case, I want to use deterministic encryption for both of the columns. And I want to generate a new column encryption key that will do the encryption for me. After that, I will also generate a new column master key that will protect the column encryption key. And I want to store this column master key into Windows Certificate Store on the client application server. And so I start the wizard and start encrypting my data. And as you can see, it takes some time. And now we have encrypted the sensitive information on that table. So let's query that table again. I run the query, and now you can see that my customer ID numbers and credit card numbers are in ciphertext. So DBA or developer who is accessing the database cannot really see the data. Let's see how we can verify that this data is actually secure and only available for trusted applications. So what I have here is a very simple trusted application called Query AE Data that I start. What this application does is it queries customer data based on social security number and returns the query result in this screen. And as you can see, the query result is in plain text. Let's see using SQL Server Profiler how the query text actually looks like. And for that, I'm using SQL Server Profiler. I start a new trace. I already have a template for that. And I run this. And as you can see, the application is generating lots of queries to my database. Let's pause this trace. And as you can see here, the query that we are sending from the trusted application is using social security number as a parameter, but the query text, the parameter value is actually encrypted here. So this means that all the traffic and between the trusted application and SQL Server 2016 is encrypted. And we are not seeing the data, sensitive data in plain text between the client application and server. And this is basically what Always Encrypted does. It makes sure that the data which is moving between the client application and server is always encrypted. So let's go back to the dashboard. Obviously, we want to now see what kind of transactions Sally has been having over the past years. And so I go to my dashboard and look at the customer history here, and we see that during the last month, October 2015, there has been an unusual amount of claimed rewards compared to the previous history. What we also see here is that the location of the history data is in SQL Server on-prem in the data center for the past 5 months, but the rest of the data and rest of the history data comes from the cloud. So we are actually using the so-called stretch database to achieve that. All the data is online, but part of the data for the history comes from the cloud and part of the data is coming from the data center. Let's query a little bit longer period of time. Let's go to 2005, January. And as you can see now, all the data for this history data comes from the cloud. Let's take a look at how to enable Stretch. So now I'm back looking at SQL Server Management Studio. And what I have here is the so-called Stretch Monitor, which will show me the current state of the Stretch database feature. And as you can see, my transaction table has been stretched onto Azure SQL database. And we see the status. And we see also that there are no local rows in the database. All the rows on that table are actually residing in Azure. Let's query that table. So now I go back to my T-SQL scripts. I enable execution plan, and I query that transaction table and see what happens. So as you can see, the query result comes pretty quickly. There were something like 2 million rows in this table. And if we take a look at the execution plan here, so we see that some of the data is actually coming from the cloud and some of the data comes from the local database storage. In this demo, you saw the full life cycle of financial data based on a real customer story. And now it's time for you to try out SQL Server 2016 and see how well these new features and capabilities fit your business. So if you want to try out SQL Server 2016 today and see how well the new features and capabilities solve your IT problems and business problems, please go to the following website that you can see on the screen and download the evaluation version of SQL Server 2016. We have also virtual labs which are showcasing the different features and capabilities, and you can go to TechNet to try out the features. I am very excited about SQL Server 2016 and the new features and capabilities it has. And hopefully after watching this video, you are as excited as I am. Thank you for watching this video.